Hello, we are now going to look at example 51, and it says the diagram shows a boat in danger at the point 0, 0. So there's a boat right here at the origin, and then the paths of the two rescue boats, blue speed and slow motion, as they depart from their positions. So A blue speed is at the position 10.5 from the origin. So right here is 10.5, and then B is -5, -2. That's slow motion right here, respectively. Blue speed moves at a speed of 15 kilometers per hour, and slow motion moves at a speed of 8 kilometers per hour. And it says find the equation of the position of each boat at t hours after departing from A and B. So we'll start with slow motion. So let's say slow motion. I'll call it SM for slow motion, right? We want to find a vector equation for it, right? And its position right here, this position was the position -5, 2, right? -5, -2. And then, so I know that the vector equation will be -5, -2. And then I know if after it departs after t time, that'll be our scalar. There's going to be some vector that goes here. So we're going to have to figure out what that vector is. We do know that the speed of this boat is 8 kilometers per hour, right? So this is a scalar quantity, but we do know a direction, right? We know the direction. If it has to go in this direction, the quantity, this right here is our speed, but it becomes a vector quantity when we know we're going to be going in the distance 5, 2, right? Now what we want to do is be able to fill this in after we're starting at -5, 2, and after t amount of time, we want to make sure we're going at 8 kilometers an hour. So to be able to do that is I'm going to find the unit vector of this guy right here. So if I let this vector be A, then I can find if I find its unit vector, I first need the magnitude of A, right? And I want the unit vector so that it's a unit, then I can propel this, multiply that unit vector, or multiply that vector when I have the unit vector, multiply by 8, and it'll be going at the proper speed. So the magnitude of this is going to be 5 squared plus 2 squared, right? Which is going to be come out to, well, the 5 squared is 25, 2 squared is 4, so that's 29. So good. And so now I'll know, I get a little bit more room. Now I'll know that I can find the unit vector of this vector that goes here. So it's going to be right over here. So if I have 5, 2, I'm going to go, I would go 1 over 29, right? But then I'm going to multiply it by 8, so it's going to be 8 over 29, root 29, right? This will give me my proper vector that I have over here, right? So a little bit more room. I'll rationalize the denominator right here, and a little bit messy, but now I can find this new vector, right? I'll multiply this scalar, right, times this vector, and I'll get 8 times 5 is 40, root 29, all over 29, and then 8 times 2 is 16, root 29, all over 29, right? Now that gives us the proper vector and direction for t time, so I can use that to write, well, I'll just write a new one because I'm going to need this guy. Well, how about this? I'll just use this right here, and then I'm going to have my scalar t plus the position vector, which was -5, -2, and this right here gives me the vector equation for my slow motion boat. But now we need to do for blue speed, right? Blue speed was this guy up here. We'll call it blue speed, right? And its vector equation is going to be, it's starting at the point, this is the point 10.5, right? Good. So I know that my position vector is 10.5 plus some scalar, and then I'm going to figure out what this vector should be, right? Now I know that blue speed is going a little bit faster. It's at 15 kilometers per hour, so it's 15 kilometers per hour, right? And its direction, if it's going this way, would have to go in basically I got to go to the left -10 and down -5, so it's -10, -5 if I want to get to that boat that's there. And then I'm going to do the same thing that I did in the other one, right? If I let this be my vector b, right, its magnitude of b would be, well, 10 squared is 100, 5 squared is 25, so it's 125, right? Or I can reduce this to 5 root 5, right? And then I can find this vector up here, if I write it right here. Well, let's see. To find that vector, I would take 1 over this scalar to make it a unit vector, then scale it up to 15 kilometers per hour, so I have 15 over 5 root 5 times the vector, the position vector, or the direction I'm going, which is -10, -5, and I can see that 5 goes into 15 3 times, but if I rationalize, right, the denominator, right, it's going to end up being a little bit more room. It's going to end up being 3 root 5, right? 3 root 5 over 5 is the scalar, -10, -5. And I can see that the 5's are going to cancel. When I do the scalar, that's going to be 5 goes into 10 twice. 2 times 3 is, it's going to be -6 root 5. And then this times this is just going to be a -3 root 5. So that gives me my scalar. Here's t plus my position that I started at, which was the point 10, 5, right? Good. And then here is my vector equation for t time of my position of blue speed, and this was slow motion. So, and then the next equation is hence determine how long it takes for each boat to reach the boat in danger, right? So, well, since the boat in danger is at the position 0, 0, that's when these guys will be equal to the vector 0, 0, and the same thing with this guy 0, 0. So this guy up here, I could solve either of these equations. I could say -5 plus t, and I know that, well, let's write it like this. -5 plus, I got 40 root 29 over 29. T equals 0, and I'll add 5 to both of those. T is going to be 5 times 29 over 40 root 5. Root 29, I should say. And if you put that into the calculator, that's going to come out to about 0.67314, and that's approximately that's an hour's time. So if you figure it out, it comes out to 40 minutes and 23 seconds. Good. And then I can do the same thing over here, and it would just be 10 minus 6 root 5 t equals 0, or 10 equals 6 root 5 t, and then t is equal to 10 over 6 root 5. And that's going to come out to approximately 0.745, right, if you put this in the calculator, and that's going to be 44 minutes and 23 seconds. Well, it looks like even though this is the faster boat, the other one's close enough, and closer can get there in a faster amount of time than the faster boat. But there you go. Thanks, guys.